Welcome back. So for this lesson, we're going to learn about one more graph that is very useful when we're trying to get a feel and for what the distribution is like for a set of quantitative data. So this particular graph is called a histogram. And the first way to do this is we're going to build a table that shows the frequencies of all of our classes. To do that, we need to know how many classes, how many subintervals I'm going to break up my data into, and then I'll get a count for each of those classes. So the first step in this is to calculate one of probably more common statistic, one that you've used before, and that's called the range. Pretty straightforward. When we're finding the range, all we have to look at is the biggest and the smallest value in our data set, which is 98 and 54 in our case, and we subtract those. So that will give us, for this particular data set, a range of 44. Now, that range of 44, I'm now going to split up into subintervals. The first step to do that is to determine how many of those subintervals that I want to have. You got to be very careful because you don't want to have too many classes. You don't want to have too few classes, so that it just needs to be in that middle range somewhere. There's not just one set way to determine how many classes you need, but I'm going to teach you one particular method just so you have a way to do this, okay? So, and this is called the power of 2 method. To do this, first you need to know how many data values you have in your data set. If I count all of these values, I'll get 35. There's 35 data values in my data set. So that's the number that's important here. So that 35, I'll just make a note. And I'm going to find powers of 2 that are just smaller than 35 and just larger than 35. So the biggest power of 2 that's smaller than 35 is 2 to the 5th power. Note that's a value of 32, right? The power of 2 that's larger than 35 is 2 to the 6th power, or 64, right? So once I determine those powers of 2 surrounding the number of data values that I have, those exponents of those powers are my options for the right number of classes to choose. So I could choose to have 5 classes or 6 classes. Either of those will work pretty well for this set of data. Let's say that we just pick 5 as the one that we want, and we want to have 5 classes for our data. Note, classes are also referred to as bins. So in some applications, if you make histograms using some software, they'll call them bins. We're talking about the same thing. Classes are bins. They're just the subintervals of our range of data. Okay, so once we have the number of classes, now I get to use those 2 numbers that we calculated, the range and the number of classes, and that's going to determine what our class width is. So my range was 44, my number of classes is 5, and so that gives me 8.8. Okay, now I want to have this class width just fall in a nice even number because it's going to be easier to work with rather than a decimal like this. And just to make sure that all of my data fits, if I end up with a decimal like I did here, I'm always going to round it up. So in this case, using that power of 2 rule, I'm going to choose a class width of 9 to go with my 5 classes. Now, if we do this right, we should have all of our data values falling into one of these 5 classes. And so now we get to start filling in our frequency distribution table. Okay, so first we need the lower limit. So again, the classes are just subintervals, right? So I just need to find out how wide each of these intervals, going from where to where is the first one, and the second one, and so on. So the lower limit of my first class, so I'll add this column, class number, my first class, I recommend you just start it at your smallest number. If you refer back to our original data set, our smallest value was 54. All right, so that's where my first class is going to start. And now I'm going to know I have 5 classes, right? So I'm just going to have 5 rows that I really need to worry about in this. I'm going to find all of my lower limits first. With a class width of 9, to get to the next class from the lower limit of class 1, I just add 9 to it. Okay, so add 9, and that's going to give me 63. And I add 9 again, right? Just all the way down this list, 72, 81, and 90. Make sense? All right, so we've made our lower limits. And so now I am going to make my upper limits. So upper limits aren't too bad. Just keep in mind, so the lower limit of class 2 will just be a value above the upper limit of class 1, right? So since I only have integer values going on here, right? That means since my lower limit of class 2 is 63, my class 1 had to end at 62. That makes sense? Since my lower limit for class 3 is 72, that means my upper limit of class, or the lower limit of class 3 is 72. The upper limit of class 2 will be 71. And you get the gist. Really, once you've found one of them, you can really just do our add 9 again. Okay, the difference between all of our lower limits will also be 9, so we can fill in all of this column as we continue to add 9 and 9 and 9 again. Okay, so there's my subintervals. So my first interval goes from 54 to 62, second from 63 to 71, 72 to 80, and so on. So the next step in creating my histogram is to count how many of my data values fall in each of these intervals. All right, so from 54 to 62, I'm going to come up here, look at my original data, and just count. 1, 2, 3, 4, 5, 6, 7 of my data values are in that interval. So my frequency then for class 1 is going to be 7. That makes sense? Class 2 will be very similar, right? So class 2, I'm going from 63 to 71. Look at the data and just count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 for that one. And then I'll put in my 11. That makes sense? You get the idea. So finish up those counts, find the frequencies for those for the 3rd, 4th, and 5th classes. Those frequencies will tell us the height of all of the bars on our histogram. So we're just going to do that much together, and we're going to walk through the rest. So you're going to fill in the rest of that frequency column, right? Once you have your list of frequencies, you can compute what's called the relative frequency, if you would like. All that is taking these frequency counts and doing something similar to what we did when we were making our bar graph in our last lesson. We're just going to find the proportion that each class is of the total. So remember, our total is 35, right? We have 35 total data values. If 7 of those values are in class 1, then the relative frequency will be 7 divided by 35. No, you just put it in as a decimal is going to be the most standard. If you wanted to multiply by 100, you can convert these to a percent if you would like. But this will give me a relative frequency of 0.2 for class 1. For class 2, I do its frequency divided by the total, and that would give me a relative frequency of about 0.31 for class 2, and I'll proceed to do that for all of the classes. Keep in mind, if you do this right, when you add up all of those relative frequencies, all those decimals should add up to 1. Or if you made it in percentages, all the percentages should add up to 100%. Okay. Now, again, some of these calculations will cause you to have a decimal that you have to round. So maybe don't exactly add up to 1, but it should be pretty darn close. Okay. Once so you've filled in your frequency column, right? Fill in your relative frequency column. Just pause the video, find the rest of those numbers, and then let's move on to make our actual histogram graph. All right. Here we are. Our histogram graph will be very similar, should look very similar to just a bar chart, okay? Except it's showing frequencies. The x-axis, let's label with lower class limits. Okay, and then my scale then will be all of those limits: 54, 63, 72, 81, 90. That makes sense. So we're going to have 5 tick marks, 1 for each class. Note, as far as I'm concerned, I know on this activity we said let's label these as lower class limits. That's great. That works. I would be perfectly okay if you clearly have identified like a class number for each of the classes. It's clear what interval is class 1 and class 2. I'm perfectly okay if on that x-axis you label them just with the class number 1, 2, 3, 4, 5. Okay, there you go. But we'll follow the instructions, and this is what this should look like. And then what would be the label of the y-axis? Oh, pause on that one. We should finish this and say that these are lower class limits for salaries in thousands of dollars. Okay, just to be clear. And then the y-axis, yeah, it's going to be our frequency. That the height of each of our bars will be the frequency of data values that occur in each of our classes. All right, so our highest frequency was what? If we look back at our table, you're probably going to have to count those, right? Since we didn't do all of them, but I think if I go up to 20, I should have plenty of room on this frequency axis. So 5, 10, 15, 20. Again, add your scale to make sure this is spot on. So again, just those labels and scales are going to be a good part of my points for this problem. So make sure we get those in there. And then we're to the point where we get to draw the bars for each of our classes. So our frequency for my first class was 7. So for this 54 bar, I'm going to go up to 7. My 63 went up to 11, so I'm going to go up to 11 on the 63 spot. So because these subintervals all together are representing the entire span of our data, technically exactly when one stops, the next class starts, we want to make these bars actually touch. I know if you use these on software, if you build a histogram on software, the software program won't often have the bars touching, but technically you should have these bars touching. And so we'll proceed and put in the 3rd class and the 4th class and the 5th class. And that's going to give us the frequency distribution of our data in what's called a histogram. Note, if you're making a relative frequency histogram, I'm not going to go through the process of remaking this all with you. All it changes for the relative frequency histogram is the y-axis. Label the y-axis as relative frequency, and then your tick marks will be decimals, right? Maybe I'm going by 0.2. So I'd have 0.2, 0.4, 0.6, 0.8, and 1. And then I can put in my bar heights, right? The basic look of your histogram will be the same, okay? Your distribution will look the same whether you made it using relative frequencies or the actual frequencies. That makes sense? All right, so again, for relative frequencies, all that changes is this y-axis. And it'll walk you through making that. So you guys are covered. Again, make this histogram, label in scales. Y-axis label is relative frequency and those decimals for that last column in our chart. Okay, so once you make your histogram, now we can determine a good idea of the distribution of our data, okay? So if the data is very symmetrical and bell-shaped, we'll often refer to it as a bell curve, then we say that the data is normally distributed. That's our ideal, okay? All of our statistic tests and things typically work best with normally distributed data. All right, so you'll see that concept come up a lot. However, in a lot of cases, you'll have skewed data. So you have a lot more values on one end of our range than on the other end. So if we're talking, let's talk in terms of average exam scores for a class. Okay, let's say we did this histogram with our statistics exam scores for our first exam. And so if the data was normally distributed, that means that on the low end, right, and on the high end, I don't have as many values as I have right in the middle. Okay, that would be my average right there in the middle. So maybe I make that average a C, so I'd expect most people to be getting the C's. I wouldn't have as many D's and B's, and I'd have even fewer F's and A's, or something like that, okay? So normally distributed, that means most get the average. So on a skewed left distribution of scores, what does that tell you? Which scores happen the most in a skewed left distribution? Yeah, the highest frequencies are there on the right side. So that tells me that the higher values happen more. So that means more of my students got A's on their exam, and very, very few were on the lower end of that scale. All right. So again, the direction of the skew is in the direction of the tail that's being stretched out. So since I have the fewest values on the left, I say this is skewed left. I have my left side drawn out. Okay. So now skewed right, the reverse of that. I don't have very many A's in a skewed right distribution of test scores. I have a lot more low values. So as a teacher, looking at that distribution, that would tell me, maybe they didn't get this so well. We better go back to ground zero and let's make sure we're understanding this better so that we can flip this around. All right. So now bimodal means that there's two peaks in the distribution. Okay. It doesn't have to be completely symmetrical like my example here, but basically you have two high spots. If you were to draw a line from the height of each, from the top of each bar, a little curve, you'd have two humps in that curve. Okay. And that would tell us that a couple different values happen the most. So I didn't have a lot of C's and D's then on my test. They're in the middle, but I did have a lot of the B's, and I had a lot of the lower values, right? So bimodal, two high spots. Uniform means that every value occurs the same amount of time, the same number of times, right? So every class has the exact same frequency. So I had exactly the same number of A's and B's and C's and D's and F's on this exam. Okay, that's uniform. So based on the type of distribution that your data has, which you can just build a histogram to see, now that will determine what kind of statistics we can do, okay? Or if there needs to be some other tricks of the trade done on the data for us to then use it. All right, so take a second. Once you have that histogram finished, describe what the shape of the distribution looks like. One of those 5 will be the one, and then interpret that. Okay. All right. So there's a histogram. So again, hopefully that's all in your notes. You'll refer to it because you're going to be making more histograms when you meet with your group, and even on some exams, you'll have to put one of these together. So make sure you have a handle on it. Zap your instructor questions if you have any, and now enjoy working with your group to make some more.